Hello again. We have another example related to electric field. And in this example, we have two charges 20 centimeters apart. If Q1 is minus 5 microcoulomb and the second charge is minus 15 microcoulomb, determine where should the net electric field be equal 0. Alright, we know there is a relationship between the magnitude of a charge and how far its own electric field could reach or cover. Now, the bigger the size or magnitude of a charge, the further the electric field will reach. Now, in our case here, I have this is gonna be Q1 and this is gonna be Q2 because of the magnitude of it's a 5 and 15 microcoulomb. So in our case, we have two similar type charge. They both negative charges, okay, which means there is a certain point or a place between them the total electric field at that point will equal 0. Okay, based on what we said before, the bigger the size of the charge, the further the electric field will reach. This means the 15 microcoulomb charge, or its Q2, well, electric field should demand in more space between these two charges. So it will be covering a bigger space here than the 5. Therefore, I can, or I can say, let's assume here will be the place, and I will call it point B. So it's closer to the smaller charge. Okay, I will say the distance between here and here, it's x, which means from here to here, I will have 0.2 minus x. This total will give me my 20 centimeter, or it's the 0.2 meter distance between the two charges. Okay, x plus 0.2 minus x, x and x cancel each other. I will go back with the 20 centimeter. Great. Now, what we said at point B, the total electric field will equal 0, which means the electric field generated by Q1 will equal in magnitude the electric field generated by Q2, and they opposite each in direction. So it's like this. It's E1 minus E2 will equal 0. This means E1 will equal E2. Sorry. Now, this take us to K, Q1 over the distance square 1. K, Q2 squared, oh sorry, not squared here, squared down. Let's erase these and go back. That will be 2, and it's the distance squared. Okay, let's replace the values. Here we go. I have K with 5 micro over x squared. K with 15 micro, and it's 0.2 minus x and all squared. Alright, let's see if we can eliminate anything. K constant, micro with the micro, they will go, which means that will take us to here. I will end with 5 over x squared, 15 over 0.2 minus x all square. Simply you can do cross multiplication, and that will give me this one here. it's gonna be 15x squared equal 5.2 minus x and all squared. Let's try to simplify our equation. If we divide both sides of the equation on 5, so let's say I'm dividing on 5, that will give me 3x squared equal 0.2 minus x and all squared. Okay, if we take the square root for both sides, I will get it's an x and the square root of 3 equal 0.2 minus x. Now let's put all the unknown or the x's together in one side, and that will end with an x 1 plus square root of 3 equal 0.2. Here that will take us that x equal, so very simple, it's gonna be plus 1, 2.7, then we say okay, and the answer will be about 0.07 meter. That will be the distance where the electric field or the total electric field generated by these two charges equal 0. It's about 7 centimeters from the smaller charge, from the 5 microcoulomb. Okay, this is the idea of finding where should be the electric field, the total electric field equals 0 if I have two similar charges in between them, where is that point. Okay, I hope you find this video useful, and we'll see you again with another one. Thank you.